Hi, Chem students. I decided to record this so that those of you who are more comfortable can go faster, and those of you who need to ask more questions can pause more frequently and ask me questions. Um, you have a paper copy of this if you'd like. If you want a digital version, feel free to come to Canvas. It's right here, and you can save it however you want and doodle on it in Notability. What you will need is your vocab handout. Either the paper copy or the electronic version is fine, but I do want to point something out about the electronic version because it's color coded, and I asked you guys if anybody was colorblind, and I didn't have anybody tell me that. I really like to use color. I'm a huge fan of highlighting, so you might want to grab some highlighters for today's presentation too, and add some color to it. So aspects of the scientific method are pink on here because some of you were asking me, you were a little unsure about what made up the scientific method. And experimental design is blue, so you can see that very nicely. All right, we're going to get started. This is our first PowerPoint of 2 for Unit 0. We have 4 essential questions. Read them with me as I read them out loud to you. What are the building blocks or the framework of thought in society? What role does the scientific method play in shifting thought? Why do scientists collaborate and communicate with each other, publishing results and repeating each other's experiments? And what is the nature of science? Start off with a quick quiz. Hypothesis is an educated guess. Well, I hope we had a little discussion, and many of you will say false. We do not want to associate hypotheses with guessing. We want to associate them with confidence, making a prediction, and the fact that they are testable. Second question of the day. Whoa, went too fast. Is science is mostly an accumulation of. Hopefully we can see that it's failures. Second to last page on your vocab handout, I did a bunch of quotes on failure. You have to have a pretty thick skin if you want to pursue science as a career, because you will have a lot of disappointment and discouragement. And that's kind of the nature of it. That's where good innovation comes from making mistakes. All right. The nature of science is made up of what are called 7 tenets. You can think of this or cross it off and call them statements if you'd like. I'm going to give you some additional words to write down to help fill in the picture, because some of these words in here are big themselves. So the first statement is that science is tentative but durable. Tentative means temporary. You can associate the T in tentative with temporary. Or you can think of it as being changeable. Science definitely changes. Number 2, it's empirically based. This is a vocab word for your next quiz. Empirical and observation down here are synonyms for each other, basically. So it's empirically based means it's coming from your key 5 senses. Your sight is the biggest one. Touch, taste, smell, and listening. We love to observe. It's very comfortable for us, and science is based a great deal on that. Is subjective. Not completely, because science is very factual in nature, but subjective is a synonym for opinion. And opinion definitely comes into play in science, especially when scientists are interpreting they're interpreting their results, they're analyzing them. They may have different opinions as to the explanation for what's going on. All right, result of innovation and creativity, it's socially and culturally influenced. It's going to differentiate between the observations, that which comes from your senses, and an inference. This is another vocab word on your handout. If you want to pause and check it out real quick, do that. If not, I'm going to give you a little context for it. An inference would be kind of like filling in the gaps of what's not there. This is a very logical and natural process. Your brain loves to put things together in a pattern and see a bigger picture. So I have 2 examples for you to talk about. If you have a connect the dots on a piece of paper, before you actually take your pencil and connect the dots, you may be able to see what's there. So that would be you inferring. You can observe the dots, but you infer the connections between them. Also, like the pieces of a puzzle. You can observe the pieces of the puzzle, but the way that they get put together and manipulated is your mind inferring that overall pattern and structure. And we're going to get to this momentarily to differentiate between theories and laws. All right, so now if you want to take out colors and all that stuff, I'm going to flip back and forth between this empty diagram, which you have, and this complete one. Please do not sit and copy the complete diagram without listening to how we get there. Otherwise, I think you might feel overwhelmed. We are going to start in the middle and build our way to the outside. You're noticing there's a series of steps here, and we've gotten a little bit into thinking about the scientific method, which is the only thing in this unit that actually has a sequence of thought or thinking. So this is what's going to go in here. And there is a step missing, so you can go ahead and label any one of these O's number 7 if you would like. I did it right here. I just put the word observation. I wanted all of these O's to represent observation because you can't turn that off. You can't stop seeing and smelling and tasting and touching and hearing. I mean, at certain times you can, but overall, like, it's just going on constantly, and you pay attention to certain senses more than others in different contexts. All right, we're going to start right here, and we're going to use a pretend situation of you wanting to go to an upcoming football game. So this would be a problem for you, and this is where all scientific thinking starts. Why with the problem? Well, because we don't like to have problems. Most people, when you have a problem, you try and solve it, and if you don't know how to solve it, you ask somebody for help. But okay, you have a problem. This can also be formed in the form of a question. Okay, you want to answer a question or you want to solve a problem. So your problem or this weekend or some weekend in the future is that you want to go to a football game. You don't know who you're going to go with or how you're going to get there. So immediately you jump into the next step, which might involve you texting on your phone. You're going to do some research. You're going to start texting your friends and you're going to say, hey, are you free? How are we going to get there? What time should we go? What should we wear? All of these things. So the minute you start asking questions, you're engaging in research. After you do this preliminary research, let's say you're going to narrow it down to some specifics. And you are going to make your amazing hypothesis. You do not ever call it a hypothesis. You don't even call it a prediction, but you would call it a plan. You're like, I'm going to make a plan. And your plan can sound very specific, and it actually can sound sort of like a hypothesis. So let's go over that. Let's say, all right, well, I texted all these people. All right, I would like to go with Sam. I'm going to go with Sam, and we figured out that her mom can take us and that we're going to go at 5:30, and Sam's mom is going to come to my house and pick me up, and she's going to take us to the game, and she's going to pick us up. So plan established. It's very detailed. I know the time, who's driving, all of that. Bam, Friday night comes along around a little bit before 5:30 when she's supposed to come. You know, you're going to start the waiting game or whatever, and that would be your experiment. So you are immediately evaluating how this hypothesis is going right from the beginning. You're thinking, oh gosh, was Sam good to ask? You know, is she a reliable friend? Is her mom going to show up on time? Is her mom going to play some cool music in the car for us? So all of these things, as soon as you start your experiment, you're doing the next step, which is kind of simultaneous. You're analyzing and you're asking yourself all kinds of questions like, man, what is going on? Is this good? Maybe I want to do this again. I don't know. Oh, wait, the night's still not over. We're still there. Okay. Bam, the night is over at some point. Whatever. Let's say you guys agreed on like 10 o'clock. Sam's mom shows back up. And at this point, you know, you're driving home and you're making your official conclusion. And you're going to reflect back on all the aspects of your hypothesis. Because remember, if you look at your definition for conclusion, it doesn't have anything to do with the end. Conclusion for us, that's why this crazy arrow is here, brings us right back to the hypothesis. And formally we accept or reject it. So just in your case, you're going to say, okay, Sam was a good person to go with, yes or no? 5:30 was a good time. Her mom was a good person to take us. You're going to reflect back on all of these aspects of your hypothesis, and you're going to say, okay, that was a good hypothesis. And if you do accept it, you might want to repeat it because it works. Some people, even if it doesn't work out, like maybe they didn't like it, they still might repeat it again. And then it might take them like 5 times. Like maybe they're just like, man, I really didn't like Sam, but you're going to hang out with Sam 5 more times before you realize, okay, I just don't want to be friends with Sam. Or maybe it was a time. Maybe you're like, all right, I liked Sam. Her mom picked us up on time, but 5:30 was like way too early. I think we should go at like 7:30. It was more fun, something like that. Okay, let's just check this out on the diagram here because I wrote a little bit more detail. So problem or question, research, formal, informal, hypothesis. I squeeze the definition in there. You don't have to. Experiment, analyze, conclusion. All right, notice all of these crazy arrows because the scientific method is interchangeable. It doesn't mean you have to go in a particular order. Different circumstances may have you starting at a different spot. And right here, especially if you reject your hypothesis, you're going to come back here and you're going to have a new problem. Like if you decide Sam was not a good person to go to the football game, you are back at square one with the same problem you had. Who am I going to the football game with? Okay, now in science, the result of going through this scientific method piece is going to result in two main categories that structure our thinking in science. And the first one, let's put right here, let's put scientific theory. I'll flash forward for you. Scientific theory. And the definition of a theory is that it explains why. You can think of it as being somewhat temporary. Pause here if you need to write that down because I'm going to go back quick. Oh, we'll stay right here actually. The other piece that you'll want to keep or add is a scientific law. Notice the difference in the definition. Theory explains why. Scientific laws do not, because these explain why they tend to be more temporary, and because laws do not, they tend to be more permanent. Let's put some math in here. A lot of times, scientific laws can be written as a mathematical formula. It is very hard to write with this pen, by the way. So we connect math generally with laws. Like you guys all know gravity. There is a law of universal gravitation. You all experience it every day. And there's actually a mathematical formula for that. Theories, on the other hand, explain why, and they're gonna be a little more temporary. There's two words that I like to associate with theories about why they're temporary, and they also begin with the letter T, and it would be the passage of time. Time goes by. That's gonna change some things, and the other big one is technology. Technology drives a lot of change. Quick example for you. Let's go to medieval times. If you got sick, even earlier than medieval times, a major explanation of why you got sick was, anybody know? It's because you were possessed by evil spirits. With the passage of both time and the invention of an awesome piece of technology called the microscope, we were able to figure out that spirits were not causing illness, but it was actually germs in the form of bacteria and viruses, because we started to be able to see cells and we got to be able to see sick and diseased cells, and then we could see bacteria in there, and we came up with a brand new theory of explaining why you got sick. So we explain it in terms of, germs, not evil spirits. And who knows? We don't have any idea what's going to happen in the future, but as we get better and better technology at the nanoscale, we may come up with way more elaborate definitions. Instead of focusing on the whole bacteria, we might be focusing on, very specific little molecules that are causing us to be sick, which we're kind of already there. All right, so these are the two big science pieces that are forming this overall box structure out here. Do you see this? This is a big box. So in the middle, we have the scientific method, which is our thinking process. That drives our thought. Out here we have science then, structuring this bigger box. Science isn't the only influence in our life that kind of frames how we see the world. I've tossed a bunch of stuff out here. And if you think about it, some of this stuff may or may not apply to you. You may be a very political person. Maybe you're not. So you wouldn't really have this here. You may be a person who practices religion and you have a strong faith, so you have a very big box here, or you may have a very small box. Same thing with your friends. Um, you can be influenced by the media, by your family. I put some mathematical words in here just for fun, like postulate and axiom, traditions, your own personal beliefs, your culture, where you live, the language you speak, your social class. So all of these come together with aspects of science, and they're forming this big box, or I kind of think of it like a frame. And then in between, I kind of labeled these little strings moral fibers. Doing the right thing kind of keeps all of this stuff together. Um, so this is what's called a paradigm. So that's why I wrote the word paradigm up here. All of these aspects make up a paradigm. And even these guys right here, black boxes, are areas that we're not quite sure how things work, but we know something is going on. How your mind works is often considered to be a black box. We have a lot of cool technology going on in terms of brain imaging, but there's a lot of unknowns in the brain. So you could put probably aspects of neuroscience as being an area of a black box, and maybe you guys can think of some from your own life. There's a lot of this in science, but we have to acknowledge it. We have to acknowledge that there are gaps in our knowledge. Okay, so just to go over this one more time, there's a lot of influences out here that make up a paradigm, and depending on who you are, you may or may not have all of these influences, or you may have them being very big or very small. All right, so let's go to what the heck a paradigm is. There was a reason that I used that crazy frame, or that big box shape filled with smaller boxes, is because a paradigm is a framework of all of that stuff. But since we're in chemistry class, we're in science class, I want to focus on those first two pieces that make up the paradigm, which are science and nature. So it's a framework of scientific theories and laws, right down here. And then really what you can do is pick, two other aspects from out here that you think are important to you when you define a paradigm. So scientific theories and laws definitely are important to your life. And maybe you want to say, like faith and personal beliefs are other. You can pick any two that you want. So that's why I left this blank. So it's a framework of scientific theories, laws, and, pick one or two other things, because you do not have to write them all. But just acknowledge that they all contribute. And what does that do? Well, that box, that shapes how you see the world. And it can happen for you as an individual. It can happen, for society as a whole and for the world. Just note here, culture and language play a big role. And I'm going to use a really contrasting example. So in the United States, we're a pretty wealthy and tech-savvy nation. If we compare our culture, our traditions, and our language, and our politics, all of these, and the media, all of this stuff, if we compare all of that to maybe like the Australian pygmies, the way they see the world is going to be so much different than the way we do, because of all of these external components being very different. The stories they start telling each other as they grow up, the way they live their lives every day, the way they cook, the way they hunt, the way they live totally differently, and the way they learn. I mean, they actually may not have as much science structuring their paradigms or their thinking as we do. Okay, so then a paradigm shift would be a radical or revolutionary change in thinking or perception, and it's usually slow and resisted. We can think of this as being something something out here completely crumbles, like a string gets broken here, or maybe this theory totally gets blown up and you have a gaping hole in your paradigm, and that's very uncomfortable. So because that is so uncomfortable, we try at all costs to resist the breaking of this structure. Once we establish the way we see the world with all of these components, we don't like to change very much. And the older you get, there's a stereotype that the older you get, the more set in your ways that you are. And I don't know if this is true with your grandparents. It is true with mine. You know, they have my grandmother has a very particular routine, you know, in terms of what she likes to eat and what time she likes to get up and what time she likes to go to bed and where she likes to sit. And that's a very small example of this, but she doesn't want any change. And in the scientific world too, sometimes change is really hard for people to accept when new ideas come along. People may have invested, you know, decades of their lives um, in pursuing a particular area of research for somebody to come along and tell them that they're wrong. It's pretty interesting. Oh, this is a crazy slide here, but I just want to introduce you to a couple more vocabulary words that come up. So whether we're talking about, remember, theories explain why, and they're very susceptible to change, whether that individual piece changes easily or it causes an entire paradigm to shift, that can happen serendipitously. You may or may not have heard of this word before. Serendipity is, please don't define it as an accident because it's not an accident. It's an accidental discovery. So it's actually a discovery that happens on accident. And Louis Pasteur, he has a nice quote that goes along with serendipity. Chance favors the prepared mind. What does this mean? It means in order for an accidental discovery to even be noticed, you have to be paying attention to it. You have to be patient. You have to be willing to see it. And I'm going to tell you a little story about the discovery of penicillin because it is probably the most famous example of serendipity in science. Somebody was studying some bacterial cultures, and he was, you know, growing bacteria in petri dishes, and he basically left the petri dishes near a piece of bread, or a piece of bread fell into the petri dishes because he was kind of done with his experiment, and he just pushed them off to the side. And, you know, he was probably eating in the lab, which you're not supposed to do. Regardless, about a week later, he came up to more officially clean his bacterial petri dishes, and he had noticed that where the bread landed in the petri dishes, it had killed the bacteria, and the bread was covered in that green mold, which maybe you've seen this in your own home. If you let bread sit, penicillin mold will in fact grow on it. So the same thing happened, and this mold, this moldy covered bread, basically killed the bacteria in this dish. And he was, instead of being mad, he was kind of excited. And this is what I'm talking about with this prepared mind. Instead of getting upset that, you know, this ruined his experiment, he took it as an opportunity to pursue something else, and turns out to be one of the greatest antibiotic discoveries in science because of his serendipitous discovery. He shifted then to convincing people to take mold, which is very hard, and we don't actually take it, we're not literally consuming mold today. We're consuming a purified molecule from the mold. But back in this time, he saw that it killed bacteria, and we had known that people get sick from bacteria. So it's like, okay, here, take this mold. And he convinced some people, and they got better, and this is pretty awesome. Somebody in today's world took his quote, chance favors the prepared mind, and chance favors the connected mind. I think if you would like to stop here for the time being and go and watch this YouTube video, it's about the slow hunch. This is pretty neat about explaining a little bit more in detail about where good ideas come from. So go ahead and watch that now and then come back to the notes when you're finished. Okay, just one other thing to talk about regarding paradigm shifts. This is kind of a cool quote. We're going to learn this guy. Max Planck is a very important scientist in chemistry. And he said, a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation goes up with that's familiar with it. This is a little pessimistic, but what he's actually saying is that it's easier to just wait for people who disagree with you to die than to try to convince them that you're right. So this is just the nature of how hard it is to shift people's thinking. Okay, a very important example of an entire paradigm shift was this guy. The P is silent. He's a very famous cosmologist. Ptolemy is his name, and he had a geocentric cosmology. If we break this word in half, geo means the Earth is being the center. The Earth is the center of the solar system. Copernicus, maybe you've heard of him, hopefully, from Earth and Space Science. Copernicus is so important to science, there's actually an element on the periodic table named after him, copernicium. It's element 112. Check out a periodic table. It's pretty cool. He got us to believe in a heliocentric cosmology. Helio refers to the sun, so the sun being the center. Now, we take this for granted, but we had to engage, society had to go through a massive paradigm shift, and this was extremely difficult. So we had thought that the Earth was the center of all. And we not only based our science on that, but religion was based on that. The Catholic Church, our traditions, everything was based on the Earth being the center. So Copernicus started taking very detailed notes. This is an example of his little notebook here. And what he was seeing in the sky didn't make any sense with the Earth being the middle. And everybody else kind of just took it for granted. That was their paradigm. And he's coming along providing some information, some data, some observations that this is wrong. And the Catholic Church was very upset with him. And this did not happen overnight. This took a very long time for us to shift because people resist this sort of change. But now we know the Earth is not the center. The sun is the center of the Earth. Just a little notation on wording. When we talk in science, please try to avoid the word proof. People still use it, and you probably will as well. But going back to our tenets of science, science is tentative, okay? It's able to change, and now we've talked about theories or entire paradigms being able to be changed and shifted with time and the creation of new technology. When you say prove, it sounds so definite, like I'm right. And truly, a scientist recognizes that when she says something, yeah, I'm right, but I'm right now. And I'm not going to say the word prove. So I always tell people, save prove for the courtroom. Let's use the word support instead. Like this theory supports that, or my ideas are supportive of. And this is a great quote to summarize science. The only thing permanent is change. Science is definitely always changing. And one other quick note. So I had put religion in the paradigm because religion is definitely important to a lot of people's lives and structuring, their perception of the world. But why don't we talk about it in science class? Well, let's go to the heart of the hypothesis. The hypothesis is the heart of, the scientific method, and it's defined as a testable statement. If you think about religion and faith, those are beliefs that are not designed to be tested. You don't set up some sort of experiment and then test whether your beliefs are right or wrong. That's not the nature of religion. Religion is something that you simply believe in. So we don't talk about it in science for that reason, because it's not testable. You don't test religion, so we don't talk about it. All right, we survived our amazing notes. Hopefully, if you've had any questions so far, you've asked me. If anything needs clarified for you, feel free to re-listen to this, or just pop your hand up and ask me a question. I'm going to go over some very detailed answers to these essential questions, and the point is to get you ready to write a little bit more scientifically, and you're going to have an essay on your exam coming up when we're done here too. So these give you really nice structure. Feel free to paraphrase and cut stuff out, but the name of the game for me was, how many scientific words can we get in an answer? Okay, so if we go back, our first essential question was, what is the framework? Excuse me. What are the building blocks or the framework of thought in society? So that's a paradigm, and we got to see they're very complex. There's a lot going on that make up a paradigm. So think about all the pieces that make it up, and that's how your thought and society's thought is shaped. This also brings me to a really, really cool example. Paradigm shifting, not in a scientific context, but like in a little kid context. So think about the paradigm of a little kid in the United States. Let's focus on the holiday of Christmas, for example. If you're a little kid, a lot of these aspects are going to be missing from your paradigm. Okay, you're not going to have, you're a 5-year-old, you're not going to have a political ideology. You're not really going to have these axioms. You're not going to be thinking about social class or scientific theories or laws. You're going to be sort of developing your personal beliefs, but what's really going to influence you as a little kid? Probably media and family, and sometimes your family restricts the media, the language that you speak, some cultures, some traditions. So a lot of this other stuff would be missing. So let's talk about, December. For a little kid in December, their whole world is probably focused on Santa Claus, which is an imaginary creature. And the cool thing is society as a whole participates through traditions in, perpetuating the belief in Santa. Everybody talks about Santa. Oh, let's go visit Santa, or Santa's not going to come if you're bad. And that's all you have to do is say that to a kid, like, well, you better behave, or Santa's not going to bring that for you. And they do it. And we have stories. We read books to little kids that are all about Santa Claus. So kids believe this is true, and then one day something can happen. Like maybe they see something on TV, or maybe a friend at school, blurts out to them, Santa's not real. And the kid can have a little bit of a shock, and if you think about that, everything that the kid thought was a reality just like comes crashing down. Some kids are more mature and they deal with this just fine, and some don't. Like they really cry and scream. And I don't know, you can think about your own personal experience. I don't remember how I found out that Santa didn't exist, but I know my brother freaked out pretty bad. All right, so our second essential question was, what role does the scientific method play in shifting thought? And I'm going to give you a very long answer. Like I said, feel free to paraphrase it. But the name of the game was, put in as many words as possible. So I'm going to pause. You pause and copy it and see if you want to paraphrase it in any way. Okay, and then we'll go to the third one in terms of, why do scientists collaborate and communicate with each other? So I thought about 3 ways to answer this, to get in some vocabulary words about valid and reliable. And this answer in particular is going to mean more to you as we go on with our second set of notes. So again, pause this, take as much time as you need to copy it or paraphrase it or just process it, and ask me any questions that you have, either on this one or on the previous one. And the final one, we already have the nature of science written in our notes. So if you want to rewrite it again for practice, bam, there you go. All right, everyone, that concludes our first section of notes, and my aim was to take a lot of vocabulary and give you sort of a visual for it to help you kind of put it all together and see how it's related.